Hello and welcome once again to another video on this channel. And we're going to be looking at numbers and the classification of numbers today. So, numbers are the foundation of mathematics. Whenever we hear numbers, they are the most basic components of mathematics, and they can be used for multiple things in mathematics. They can be used for counting, they can be used for measuring, indexing, and also keeping things in order. So numbers serve as the foundation for everything that you learn in mathematics or the everything you learn at the beginning of mathematics. Let me put that way. And numbers come in different forms. So that is what we are going to look at today. Remember, I established that numbers are basic components in mathematics, so they are also classified as such. We start with the number hierarchy. So we should be aware that every number that we are going to ever use belongs to a particular set of values. So the numbers that we use to count from 1, 2, 3, and so on, those are regarded as natural numbers. They are natural numbers. All numbers from 1 to infinity are natural numbers, counting numbers. We also regard these natural numbers as counting numbers. And this is the symbol that is used to represent counting numbers. Then we have whole numbers. Natural numbers are under whole numbers. So when you come across natural numbers, some natural numbers are also whole numbers, but not all whole numbers are natural numbers. So the only exception to the rule for natural numbers and whole numbers is that for whole numbers, zero is included. So for natural numbers, you have one, two, three, and so on. But for whole numbers, you include zero. Zero is included. Then we have what we call integers. Integers are positive and negative whole numbers. So we are going to be including our negative whole numbers, starting from the smallest negative whole number you can think of to the largest positive whole number you can think of. So and zero is also included. That is for integers. And this is the symbol, a Z, a customized Z is used to represent it. And then natural numbers are own and whole numbers are under integers. They are under integers. Then we have mm, rational numbers. Rational numbers. So when we talk about rational numbers, excuse me, rational numbers are, to put in plain terms, they are numbers that can be expressed as a fraction. So you see this 1 over 2 can be expressed as a fraction. You can find the answer to this response, to this fraction. 1 over 2, we have 0.75. This can also be represented as a fraction. Representing that the fraction will be 75 over 100. And we can get a finite answer for it. Uh, then we have real numbers. Real numbers are every rational and irrational numbers. So compared to rational numbers, although I didn't put irrational numbers under this hierarchy, so irrational numbers are numbers that cannot be expressed as fractions. Irrational numbers. We'll see the difference between rational and irrational numbers very soon. Then we have complex numbers. All the numbers that we have treated, real numbers, rational numbers, integers, whole numbers, natural numbers, they are also under complex number. It's just that for most of them, the complex component or the imaginary component is zero for most of them. So when you are now dealing with proper complex numbers, the imaginary component is not zero. So that's the number hierarchy. Natural numbers comes first, which is under whole numbers, which is under integers, which is under rational numbers, which is under real numbers, which are all under complex numbers. Then we have the basic classification of numbers. So natural, whole numbers, and integers. We explained it. Natural numbers are numbers that are used in counting. They are used in counting. So you have a set of 1, 2, 3, 4, 5, and so on. So as long as you are counting, the numbers that you are using in counting are natural numbers. Then we have whole numbers. Whole numbers are numbers are the natural numbers including zero. So zero is the only addition that is made when dealing with whole numbers. Only addition that is made to natural numbers when talking about whole numbers. And then we have integers. Integers are whole numbers plus all their negative values. So whole numbers plus all their negative values. And then the difference between rational and irrational numbers. So these two types of numbers, rational and irrational, they make up what is known as uh they make up every real number, every real number that you're going to experience, that you're going to come across. They are either going to be rational or irrational numbers. They are either going to be rational or irrational numbers. So for rational numbers, any number that can be written as a fraction where a and b are integers and b is not equal to zero. That means your denominator, when we're dealing with fraction, the number below the division sign is the denominator. So the denominator cannot be zero. If not, this rule does not hold. So examples of rational numbers, we have 1 over 2, 1 over 3. This adds up to, I'm sorry, it solves to 0.5. This solves to 0.333. It's a recurring decimal. This solves, 5 is a rational number because you can write it as 5 over 1. So it indicates that all integers are rational number. When you have a number, 5, 10, 10 can be written as 10 over 1, 11 can be written as 11 over 1. So all the numbers that can be represented and written as a positive and negative fraction are rational numbers. They are rational numbers. Then we have irrational numbers. You have a number that cannot be written as a simple fraction. So you have the decimal equivalent of that fraction or of that number going on forever, and there's no repeating pattern. So examples of such numbers, we have the pi. Pi is a constant used to solve for areas of circles and the likes. So the pi, it never repeats, but it is a very, very long decimal. Then we have root 2 when we're dealing with irrational numbers, surds, root 2, root 3, the square root of uh, numbers that are not perfect squares. Then we have the Euler number. This is also a constant. And then we have, okay, I already gave example of root 3, root 5, and then golden ratio. So for irrational numbers, the decimal expansion never terminates and never repeats. So it never ends and it does not repeat itself. That's what we have for decimal expansion. I'm sorry, irrational number. And then comparing between real and complex number or real versus imaginary numbers. So when we are taking the square root of a negative integer, an integer is either positive or negative values of whole numbers. When we take the square root of a negative number, it is quite difficult to work that out. So the square root of a negative number produces a result that is complex. It produces an imaginary number. So the problem is root of -1 is unknown. It's not easy to find. So the solution to that is that I is equals to -1. We equate root of -1 to be equals to I. So this is regarded as the imaginary unit, and it opens up a whole new number system, which is regarded as the complex number system. That is something for another day. But whenever we are dealing with a real multiple of I which represents root -1, we can write it as bi. That's the uh number we are dealing with times I. So see how it is expressed. 3i is an example, -5i, root 7i, they are all examples. So if I is equals to root of -1, if you take the square root of both sides, we know that I squared will be equals to 1. So complex numbers are always written in this form. You have the real parts and then the imaginary parts. The imaginary part is always accompanied by I. So whatever number you write is always accompanied or is always written beside I. I meaning -1, root of -1. Then also to take note of that, the complex number combines every number system into one. So it includes the complex numbers. It's just the only difference between the complex numbers and the whole numbers. The whole number is also a complex number. It's just that for the whole numbers, the complex part is 0. The complex part is 0. Then we also have even versus odd and prime versus composite numbers. For even numbers are numbers that can be divided by 2 without remainder. So not just numbers, you can say integers, whether positive or negative numbers. So they are numbers that can be divided by 2 without remainders, while odd numbers leave remainders when they are divided by 2. They cannot be divided by 2 without remainders. So we've seen the different examples from -4 to 6, 8, 10. So you are skipping a number. If you start from 2, skip, you get 4, skip a number, you get 6, you get 8, you get 10, and so on. Then for odd numbers, numbers that cannot be divided by 2 without remainder. And then we have prime and composite numbers. Prime numbers are numbers that have exactly 2 factors, itself and 1. So 1 is not included. 1 is not a prime number because 1 has only 1 factor, so it cannot be regarded as a prime number. It has 1 factor itself. And then we have composite numbers. Composite numbers are numbers that have more than 2 factors. More than 2 factors, and they can be divided evenly by other numbers. So you have numbers like 10. 10 can be divided by 5, it can be divided by 2, it can be divided by itself, it can be divided by 1. So um the thing to take note of, you know that 1 is neither a prime number nor a composite number. I mentioned that now. And 2 also is the only even prime number. Alright. Then we have cardinal versus ordinal numbers. Cardinal numbers are numbers, the best way to put it, cardinal numbers are numbers that are used to count objects. So when you are counting a certain number of objects, number of books on the shelf, number of people at an event, you use cardinal numbers. So it tells us how many of something there are, and it answers the question how many, how many, how many. So there are 7 books on the shelf. There are 5,000 people at the concert. So that number 7 is just a count of the total quantity that was there. So you have more examples: 1 apple, 12 eggs, 100 students, 0 mistakes, apologies, and so on. So cardinals are numbers that are used for counting and quantity. So they are the most common type of numbers that we deal with. And then we have ordinal numbers. It helps tells the position or order of something in any sequence. So when you are asked in what order is something, for example, when dealing with pages, you're on the 10th page of a book. This is the 3rd day of the month. So ordinal numbers, ordinal, order, ordinal. So she finished 3rd in the race. That's telling us her exact position, not a quantity. So we have first place, second in line, 10th chapter, 21st day, and so on. So ordinal numbers are essentially used for ranking, date, sequence, and any other time order that matters more than amount. So we've seen numbers hierarchy, we've seen the components, the hierarchy of numbers, how natural numbers are below, all natural numbers are whole numbers, all whole numbers are integers, all integers are rational numbers, and all rational numbers are real numbers, and all real numbers are complex numbers. So they are all part of each other. The smallest set is natural numbers. The set increases as we go to complex numbers. And then we also saw the difference between the natural whole and natural numbers, whole numbers, and integers. And then the difference between the irrational and irrational numbers. So I believe with all this, we have a good understanding of what numbers are and the type of numbers that we can come across. Thank you. Don't forget to subscribe. I'll see you in the next video.